Hello, ladies and gentlemen. Welcome to What is Machine Learning? We have a big audience today, so let's just jump right into it. This is presented by LeadScorz. Why are we here? So we're here to very quickly get an understanding of what machine learning is, and in particular in the EDU space. LeadScorz is a Seattle-based analytics firm that provides predictive lead scoring services to the educational sector. My name is Harry Brailsford. I'll be your host. So the short answer with respect to what is machine learning concerns Netflix. It's a commonly used example. Have you ever noticed when you go up on Netflix, it just knows what you might like to see? They pioneered a lot of paradigms in machine learning, and part of it is it starts with the training data. It starts with your historic purchases on Netflix. It starts with recommendations they make that you accept. It starts with recommendations they make that you decline, and all of that is recorded behind the scenes, if you will, to make the very best recommendations for your viewing pleasure up on Netflix. And then that has a way of endearing Netflix to you. You remain a customer and so on. But the long answer is it's testing, testing, testing. And for those of us that came from other industries, sometimes that's an adjustment we have to make, that this is an ongoing journey. And quite frankly, it's probably never completed because, as I'll show a little bit later, in the data science area, we're always and continuously learning. Finally, again, I want to emphasize, don't be embarrassed if you're not conversant in machine learning, the definition of it, and a very basic understanding. That's our intent here today in a reasonably short period of time, is to arm you with the machine learning conversation, get you back to your day job, and you're better off for it, and we'd love to have further conversations. So an EDU example that I'd like to present concerns an online university. 10,000 students. They've enabled the machine learning technology to help them be more relevant in their recruiting efforts. So for example, they want to make sure that they don't have the wrong conversation with the wrong type of student, perhaps a low-scoring student who is unlikely to convert, doesn't want to be bombarded with emails and phone calls, versus a highly scored student wants to have a more meaningful engagement with the online college to see if, for example, the master's degree program is proper for them to consider. So that relates to using the historic data to discover these different types of student groups and improving their internal processes. And as a function of that, the online university has shared with me that it's improved the student experience. So the CSAT scores, the satisfaction scores, have gone up, and that's because they're better addressing the needs of individual students appropriately. Interestingly, I'm going to change the direction here for a moment. Interestingly, over in the curriculum development area, as part of my research, IBM has done a lot of research in education and machine learning. And what they have discovered, what they've done, what they're doing, is to think in terms of machine learning to deliver relevant courses. And so much like Netflix, you would have an understanding, the student would have an understanding that this course makes sense right here, right now for that student. And quite frankly, that student's learning style. So maybe we're taking into account different learning styles. We're taking into account some learning challenges like ADHD, etc. That's what's going on over in the curriculum area. Let's dig a little bit deeper. So digging deeper, in order to consider machine learning, 3 elements must be present. Number 1, a pattern exists. So rating movies on Netflix has a pattern. Number 2, we cannot pin it down mathematically. That's why we are using machine learning to literally learn from the data. And number three, you have to have the data. Machine learning always starts with data. You're going to have a training period for the machine based on data. You're going to hold back some data as truth data to validate your findings and the machine's ability to predict outcomes and so on. But your goal is to extract knowledge or insight from the data. There's some amount of automation in the process, of course. That's why it's called machine learning, and if it weren't, you'd be trying to define wisdom manually. So you're applying an algorithm to help answer questions that are being presented. And that automation, again, would be the computer. But the machine learning is not just about machines. The journey requires you to make many smart human decisions as part of the process. So it's not only machines. Let's move on. There's two main categories, supervised learning and unsupervised learning when we think of machine learning. So supervised learning, making predictions using data. This is also known as predictive modeling. I recently took a great online course where this was presented as ham or spam. The scenario was training a spam filter to review incoming email and determine if it was non-spam, so we call that ham, and should be placed in your inbox. You probably know the rest of the story. The other type of email was spam and placed in the trash folder. The goal is to predict a specific outcome. Another view is that the primary goal of supervised learning is to build a model that generalizes. It accurately predicts the future rather than the past. Unsupervised learning. This is the process of extracting structure from data and learning how to best present the data. For example, you could segment students and potential students into clusters that exhibit similar behaviors. So you might find that there's a couple of groups of students displaying similar behaviors within each group. For example, the two-year degree-seeking student cluster might have renter status as a predictive variable. Master students might have home ownership as a tendency. But this variable is dissimilar between between the two groups. Most importantly, there's no right answer. So how does it work? First, you train a machine learning model with training data, also known as labeled data. This data has been labeled with the outcome as the email, ham, or spam. This is called modeled data because the model is learning the relationship between the attributes of the data and its outcome. Such a relationship, using our email example, might include length of text strings, specific text in an email, length of message, etc. Second, you make a prediction on the new data for which the label is unknown. It's actually easy to announce. A new piece of email arrives. The machine hasn't seen this piece of email before, and it predicts that this is a piece of email. This piece of email is ham, not spam, based on everything it knows. Bottom line, the model is learning from past examples using inputs and outputs, and then applying what it has learned to future inputs in order to predict future outputs. I ask you, does that make sense? Discovery. So the discovery process, I'm going to offer it's part of any business model that we go through the discovery process. So here are the questions to ask. How do I choose which attributes in my data to include in the model? How do I choose which model to use? How do I optimize this model for best performance? How do I ensure that I'm building a model that will generalize unseen data? And can I estimate how well my model is likely to perform on unseen data? So the value or the admission price alone is worth it to know the right questions to ask. I'm not suggesting at the end of this webinar or even in your career path you'll be able to answer all these questions. That's where you would work with qualified professionals, data scientists, and so on to walk through the discovery process. Machine learning for dummies. Well, a spoiler alert, such a book doesn't exist, likely because you'd have to be a very smart dummy to engage in the machine learning motion, so there might be a branding problem. But I recently attended a LinkedIn course that was called Machine Learning for Dummies. And essentially what's going on here is the machine has to learn what animal groups, or in the case of this, it could be the fruits, belong together. Basically, at the end of the process with machine learning, it would know to group a horse and a cow with horses and cows, and an apple and a pear with the appropriate fruit group. Compare and combine. So this is an interesting part of the conversation. And again, my intent here was to have a very efficient learning session with you so you can walk away richer for the experience and have a basic understanding of what is machine learning in EDU. And thank you for joining us. So let's talk about compare. So in the predictive area, there's the machine-based rules, and then there's more of the free-form discovery process. And with the rules-based learning, what we're contending with is that the machine only knows how to behave with a static set of rules. And so, quite frankly, that process can be a couple of nanoseconds faster when we're working with the algorithm. Now, the other way is much more free-form, the predictive model, and it's more dynamic. And I like to think of it this way. I was just explaining it to an individual the other day, that the best way I can explain it is it's not necessarily the type of static chart we're all used to, say a pie chart or a bar chart. I like to think of it as an old black and white World War II movie. And do you remember the way that they displayed radar, and things would appear as a blip on a radar screen as the tone arm went around? So perhaps you would see a boat that was incoming, a plane that was incoming, a false read. You had to understand how to interpret radar. In this case, I liken it to the same thing in the predictive area, the free-form approach, that you have these little radar blips that would show signal of strength on the screen. And then we could also detect what I would call false positives. So you can appreciate that approach where we're taking, going back to EDU, we're taking a lead for a potential student. So it's a candidate, and we're taking basic information on that individual, and we're running it through our algorithm. And we're going to look for signal of strength. And we're going to come back and we're going to say this individual is a high score, say up in the 80s, so 80 out of 100, and is likely to convert and be successful. And then there's other individuals who might have a low score, say a 25, and we can decide what to do with those two different types of students. Maybe something below a 30 goes to a nurturing campaign. An 80 would have the hotshot team, the admission rep, give them a call right away. Next topic, combining machine learning with cloud. So this is very important because the industry is changing very, very quickly. Every single day you see articles about the transformation occurring in cloud computing. For example, Amazon Web Services is a market leader in the hosting of different solutions like the LeadScorz predictive lead scoring model. And Amazon is thriving. You see some older school technology companies that are trying to make that transformation. But here's my point. If you combine machine learning with cloud computing and you have that SaaS model that's portable and replicatable and expandable, you really have a killer combination. And a shout out, some of you on the webinar will remember the name Cray Computing. A shout out to Cray Computing, the supercomputing company, because This plays right into their strength with supercomputers that can crunch mass amounts of data very quickly, and all under the guise and paradigm of machine learning. So I want to thank you for joining up. A couple of follow-ups. I'm going to send you a machine learning article that was recently published. I'm going to send you a replay link to this webinar. And then I'm also going to encourage you to have a conversation with us at LeadScorz in terms of conducting a pilot program. So thank you very much for joining us, and have a great day.